Hello, my name is Ishwar and today I am going to talk about the sharpening filter in the frequency domain. The sharpening filters are a filter which is used for the image enhancement. The image enhancement in frequency domain are used. Before going on to the topic, we have to know what is image enhancement. The image enhancement is the process of making images more useful, or the reasons for doing this include highlighting the interesting details in the image, removing the noise from the images, and making images more visually appealing. And we have to know what is spatial domains and frequency domains. The spatial domains are the image enhancement techniques can be divided into two parts, which is spatial domain techniques and frequency domain techniques. The spatial domain techniques directly manipulate the image's pixels itself, and the frequency domain techniques have the manipulation of the Fourier transform or the wavelet form of the images. For the moment, we will concentrate on the techniques that operates in spatial domain. The basic structure in frequency domain, the basic structure for the filtering in the frequency domain is simple. First, we will take a input image and convert it into the Fourier transform of the image. Then we will apply the filter function. Then we will have an inverse Fourier transform of that filter, which is converts back to the image form. Simple. This is the basic step for the image processing. The basics of filtering, which is we can just multiply the input image by -1 x plus y to the center transform of u is equal to m by 2 or v is equal to n by 2, where m and n are even numbers. The shifted coordinates will be integers. Then we have to compute the DFT or discrete Fourier transform and multiply the filter function Then we have to remove the inverse discrete Fourier transform of the image and obtain the real part of the result, and multiply the result in to get the original image. Then we have to know what is the sharpening of the images. But after applying completion of the image processing, we have to apply sharpening of the edges. The sharpening has the edges and fine details of the characteristics by sharp transitions in the image intensities. Such transitions contribute significantly in high frequency components of Fourier transform, intuitively the attenuating certain low frequency components and preventing high frequency component result in the sharpening. The sharpening filter frequency is as simple as HUV is equal to -1 of HUV, which is just attenuating the frequency, or the high pass filter is applied to high pass filter or low pass filter is applied to the frequency. Then we have to apply blurring of the masks. The blurring of the mask is applied. All the values of the blurring mask are positive, and the sum of all edges values is equal to 1. The edge content is reduced by using blur mask. As the size of mask grow, more smoothing effect will take place, and the blurring of the masks takes place. Now we have to know what are the different types of blurring mask. We have to use a derivative mask. The derivative mask is simple as just converting the positive values to the negative values and summing the derivative masks to equal to 0. The edge content is increased by derivative mask. As the size of the mask grows, the more the edge content is increased. The relationship between blurring derivation mask with the high pass filters and low pass filter. The relationship between the blurring masks, derivative mask and high pass filter is using that the blurring masks are called low pass filters and the derivative masks are called high pass filters. And the high pass filter frequencies and the low pass filter frequency components denotes that the pass frequencies of the smoothing edges of the components. Ideal low pass filter. Now this is a technique to image enhancement. Ideal low pass filter is where it will take out all the 1 in the place of inside the zeros, and output will be 0. Then a ideal high pass filter is reverse of the low pass filter, which converts a 0 to 1. which converts 0 to 1. This is a form of high pass filter, which is the Butterworth filter, Butterworth high pass filter. It uses a D function, which is the cutoff distance of the image, It also uses the same method, but the distance of cutoff is very smooth. Next, the Butterworth filter, we can see the different results of the Butterworth filtering. Here we can see the applied frequency is very smoothened out and the edges are detected in the form. Next, the concept of filtering of low pass filter remains the same. Next is the low pass filter, Gaussian type low pass filter. Gaussian frequency, we are going to take a Gaussian noise type low pass filter. In the low pass filter, the smoothening curve transition is due to the each point value, and d of naught can be exactly defined. The Gaussian high pass filter has the same concept as the ideal high pass filter, but again the transition is more smooth as compared to the ideal filter. In the sharpening Laplacian filter, in the Laplacian filter, we are going to apply Laplace transforms, which converts the main signal, which converts the frequency, which converts the spatial domains to frequency domain. This is a simple Laplacian mask is applied to the image. Conclusion: the aim of the image enhancement is to prove that the image of the viewers are to provide better input for the other automated image processing techniques. There is no general theory for determining what is good enhancement technique. It comes to the human perception. If it looks good, it is good. And let us recap again. We have learned what is image enhancement techniques, what is image enhancement, and what is spatial domains and frequency domains, and how to convert into a frequency domain, how to convert an image into the frequency domain. Then we have seen the basics of the filtering of frequency domain. Then we have learned different filtering techniques, which are sharpening of the filter, blurring masks, derivative masks, and different blurring masks, which is the relation, what is the relationship between blurring masks and derivative masks. And we have to know the high pass and low pass, and we have known what are ideal high pass and low pass, and we have seen best high pass filters and low pass filters, which is Gaussian and Butterworth filters, and we have seen another type of image enhancement technique, which is the Laplacian sharpening, and we have known that in general the theory of determining the image enhancement is based on human perception. Thank you.